STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Angelica Garcia and Jonathan Schlueter. Hello and welcome to NASA STEM Stars, where students connect firsthand with NASA scientists and engineers to learn about NASA missions, career paths, and opportunities. Today's topic is virtual reality training. I'm your host, David Alexander from the Armstrong Flight Research Center. And joining us today are two software and simulation engineers from the Johnson Space Center's Virtual Reality Training Lab. We have Angelica Garcia and John Schlueter. Welcome, both of you guys, to the show, and thanks so much for actually being here. Angelica and John are actually going to share a bit about their background, their career experiences, and the work that they do for NASA, and actually specifically how they create simulations and support of astronaut training. So as you're listening to the show today, and when they're actually sharing their stories, we want for you guys to actually come up with some questions to ask them. So about half of our time is going to be devoted to answering your questions. So please answer those questions in the YouTube chat throughout the conversations today, and we'll try and answer them all before we wrap up for the day. So let's get started. As I mentioned, Angelica and John are software simulation engineers at the Johnson Space Center's Virtual Reality Training Lab. And the lab has actually been in operation since the early 1990s, developing tools and software for astronaut training and extracurricular activity, or what you would actually be known as a spacewalk. So, Angelica and John, we are very, very excited you're here and looking forward to hear about your NASA story, your work with NASA, and any type of insights or tips that you may have for our students. So with that, I'm going to turn it over to you, Angelica, to get us started.
Thank you so much, David. As he mentioned, my name is Angelica Garcia, and I work at the Virtual Reality Lab here at Johnson Space Center in Houston, Texas. So let me share a little bit about my background with you guys. I went to school at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and I received an aerospace degree in engineering, and then I pursued a master's degree at the University of Central Florida, where I did modeling and simulation. There, my focus was a little bit more in virtual and augmented reality, specifically for training environments. So let's talk about my journey and how I got to where I am today. So while I was at Embry-Riddle, I absolutely loved airplanes. I quickly got involved in a co-op program at Gulfstream Aerospace. They make private jets, and I was very excited. I got to experience 5 different internships there and work in all different types of departments. I got the chance to work in the shop floor, hanging out with the mechanics, learning as much as I could. And through that journey, I realized that I really liked simulation. So while also I was in school, I joined and networked with people in different organizations like the Society of Women Engineers, and got involved in a lot of different things throughout the journey. So once I finished my bachelor's degree, I realized that I wanted to continue pursuing a degree in simulation. So I continued on to the University of Central Florida. And throughout that process, I got a chance to intern at Langley, where I started exploring virtual and augmented reality, and I knew that's exactly what I needed to do, and I needed to wrap up my aerospace engineering degree with my love for simulation and virtual reality, and thankfully that brought me to the position that I am here today.
It is outstanding. John, how about you? Let's hear a little bit about you as well as your journey to NASA.
Yeah, so just like Angelica, I'm John Schlueter, and I'm working at the Johnson Space Center's Virtual Reality Training Lab. And I grew up all the way up back in Iowa, and born and raised, and I went to Iowa State University and studied computer engineering for my bachelor's. And through that, I got connected with a research lab on campus, the Virtual Reality Applications Center. Didn't know a whole lot about VR or simulation at the time. And through that, I got to see a whole lot of different funded contracts from anyone from the Department of Transportation to the military to private companies working on trainers for their own new systems. And so with that, I loved the work and I loved the people I was working with so much, I wanted to see where it could go. And so I continued on to a master's in both computer engineering and human-computer interaction with the same research lab. And then with that, I focused on how virtual reality and augmented reality can be used to help build training environments and help teach people valuable skills, both in the field or in an office where you need to visualize different aspects. And so I had 3 separate internships down in St. Louis with the Boeing company, and that got me kind of exposed to the aerospace industry and got a little familiar with that. It was more in the hardware spectrum, and I know I wanted to build more software in the graphics side of things. And so with that, I never expected I was going to land in the space industry, but there was a retired astronaut that I got to know through Iowa State, and he connected me down with the virtual reality training lab down here in Houston, and it was a pretty easy transition from one to the other of training instead of private companies, you got to train astronauts. It was a pretty quick transition for me. And so some of these pictures I got to work on when I was at the Iowa State lab, I got to build a VR application for a virtual game day experience. So you could actually go on the field and see what it would be like if you were a player on the field with the crowd around you. And we had our flagship facility we called the C6. It was a VR cave system. So you'd close the door behind you, you'd go inside, and you'd see 360-degree virtual reality, similar to what you'd see in a headset. And when I'm not on screen or when I'm not in front of a computer, I usually like to get away from the computer a little bit. So I like to go explore. That's out in Zion National Park out in Utah.
Okay, that's outstanding. That's really awesome. And for students, remember, if you have any questions for John or Angelica, you can type those questions in the chat, and we'll answer as many of those as we can before we wrap up today. So we're actually going to take a closer look now at virtual reality simulations that John and Angelica create for astronaut training. So crew safety is the #1 priority for astronauts working in outer space. Angelica, can you tell us a little bit more about SAFER and how it contributes to astronaut safety on station?
Yeah, absolutely. I can give you guys a brief background on SAFER, and I have a couple of videos to show you. So SAFER stands for Simplified Aid for EVA Rescue. In other words, it's a jetpack. So whenever an astronaut comes outside of the station to perform a spacewalk, they wear their spacesuit. Attached to their spacesuit, they have a backpack. And then within that backpack, there's a jetpack, so the SAFER system. So before they even launch to the space station, here on ground in Houston, they train for a long time. One of the systems that they have to train for and certify in is SAFER. So what we do at the lab is we put the astronaut in VR. So we put a helmet on them, just like you saw in the image. We give them the actual hand controller for that unit. And in virtual reality, we can put them in any part of the external of the station, and then when we turn on our simulation, they begin to tumble away. So we simulate the system failing, and we simulate them tumbling away from station. Now they can power it on after a couple of seconds, and they can perform self-rescues. So this is what they train on. They train on how to rescue themselves if every single system fails, and they have to save their lives by flying back to the station. Now they perform a couple of these runs, and as you guys will be able to see in the video, they begin at any point throughout the station. We can configure it however we want. We can actually turn on and off the lights to simulate whether we're passing through a dark phase or whether we're closer to the sun. As you can see, we can also change the rate at which they separate from station. And then once they power their hand controller on, the system engages and they can begin flying themselves back to station. Now, they do complete several of these runs throughout their time in training. And the cool thing about the system is that not only do they get to do it in VR here on Earth, but they also get to do it again as a refresh trainer on board of the station. So now if we go back to the slide, on the picture in the right, we have one of our astronauts actually performing a rescue case on board of the International Space Station with one of the systems that we also provide, which is the VRT, the virtual reality trainer. So as you can see, he has a headset on, the same hand controller, and a laptop. So they're using the same system that we use here on ground, on board. So it's really good that they get a chance to refresh train on that system once they've actually arrived to the station, because between the time that they train here on Earth and the time they get to fly to the station and they actually have to perform a spacewalk, it could be a really long time for them. So it's a really good idea for us to be able to provide a refresh trainer for them to be ready for anything. Now that covers a system that we use today for our astronauts to get them ready and keep them safe. But Jonathan is actually working on a really interesting project for our Artemis program. So I'm going to turn it over to Jonathan and let him tell you guys a little bit more about that.
Yeah, so just like we use all of our simulation environments to train for the ISS, we're starting to look toward the future to see what kind of new training is going to be needed. And right now our mission is to go back and put boots on the moon by 2024. And it's easy said, not so easily done. And you got a lot of training to build up what kind of risks are involved with this, what kind of problems you're going to see. And so we are building a simulation to help train that and graphically represent a lot of what they're going to be faced with whenever they get there. So for this lunar surface training, we took the Lunar Reconnaissance Orbiter camera, the LROC, which has been orbiting around the moon for many years now. We've been taking a lot of that data, and we can take those images, and they have a digital elevation map, which you can take that and put it into a 3D model, which then we load it into a game engine, and then we can add all sorts of the other simulation elements on top of it. And so in this simulation, you've got to the best of our knowledge, a 3D representation of what the terrain is going to look like. We also have in this environment scanned in samples of real lunar rocks that they brought back during the Apollo missions. And so we brought those in, so anyone who's in this simulation, they can pick up these rocks with their virtual hands, take a look at them, they can see mineral deposits, they can see different coloration, they can see the divots in the rock, so they can see what they're going to be looking for, and those are actual samples that were taken, so we don't have to guess and check. And on top of this, we also have a multi-user environment, so you can see not only yourself in it, but you can have multiple people in the same place. One of you can be on the lander, another can be driving around a rover, and a third can be taking soil samples somewhere else on the soil. And so I have a video we can show you, and I'll talk you through a little bit about what's going on. And so right off here, you got two different people in the same environment. That vertical fin is actually a solar panel on one of the designs they have for the rover. And so you can see that's being driven around. The rock field that you see, we actually synthetically generate because the imagery we have isn't high definition enough to be able to see where each individual rock is. But from Apollo pictures, we know they're there. So we can generate different rock fields based on different distributions that we need. And so while he's driving around, you can see the sun angle changing too. And since it's a fully synthetic environment, we can change the time of day. We can change the angle of the sun. And one difference that's between the Apollo missions and the South Pole has a much darker and lighter regions because the sun is right on the horizon. Whereas a lot with the Apollo missions, it was up in the air, so everything was brightly lit. And so the crew member in the distance there, you can see that
process that NASA throughout the agency have is pretty much the same. So, especially onboarding, having to get, your cards, access to specific things, and just the process of the way the work was initially took some time, but because I had done it already as an intern when I started full time at NASA, and it was not right away, it was about a year and a half after I interned, I already knew the processes. I already know how things worked. I knew where to ask questions, who to reach out to if I had issues with anything. So I was pretty comfortable with the culture of the agency. So it was actually pretty nice to have interned before I came in on board full time.
Oh, okay, fantastic. And while we still have you here, we had another question. Is SAFER only used in cases of emergency, or is it used regularly for EVAs?
That's actually a great question. SAFER is a redundant system. So there is a series of failures that need to have happened in order for them to be able to use the SAFER system. But it is right now required to be worn before they come outside of the airlock and perform a spacewalk.
Okay, great. And John, we had a question come in for you. How did you decide which college you would like to attend or go to?
So growing up in Iowa, I always heard quite a bit about Iowa State as far as being a good engineering college. And so I went into computer engineering just based on how I enjoyed video games at the time, and a bit of a stretch, but I enjoyed it. And I thought that would be a really neat opportunity to kind of express a bit of an art form in a way. And so the two of those kind of connected, and it didn't hurt that they also had one of the best virtual reality / simulation departments I think I've ever seen. That C6 that I was talking about, that 6-sided cave system, is one of the highest resolution in the world. I think the only other duplicate was in Saudi Arabia, I think. And so that was a big pull into, okay, they're serious about it. They're really invested and interested in seeing what simulation can do for the medical industry, for the military, for private companies doing their own training. And so kind of pulling all that together, I thought, okay, it's not too far from home and it's got all these other benefits. It was about the perfect opportunity, I think, for me.
Oh, okay. Another question here for you, John. Is the VR program for the moon, Artemis, going to be available to the public?
So there's no plans for that just yet, and we're still pretty early on. We've got 4 more years before we actually get to the moon, and there's going to be a lot of training involved, and it's going to change pretty frequently based on what we need to modify that to train them on. Now, that said, I actually has been built on publicly available tools. So it's based on the Unity 3D game engine, which anyone can go out and download and play with. There's hundreds of thousands of hours of guides online. You can look at how to get started with that. If you know how to program, great. If you don't, you could still get started with it, and there's guides on how to graphically do everything. And so the tools that I used to build a lot of this is all available for you guys to download besides the actual 3D models themselves.
Mm-hmm. Okay. What about for younger students? Do you have any software or any type of tools that the younger students can possibly use to get started with VRs or game simulations?
Let's see, game simulations. I started in the first Lego League. They actually had a kit you could buy, and it was a very simple program you could get that was the very basics of coding in the visual form. So you could actually put blocks in and kind of make these blocks and link them together to have this robot that you built do what you told it to do. And that's kind of how I got a little bit of my start. And then I started into looking at these 3D game engines, and they make them very accessible. And you don't need a whole lot of coding background to get started. But if you want, you can figure out little pieces here and there and do these small bits of code that then completely change the situation, which is pretty fun to see that you did that.
Mm-hmm, mm-hmm. And that's great. I'm glad you answered that the way you did, because another student had a very similar question in which they were asking how you got it started altogether in VR. Let me ask you this. We're talking a lot about internships and mentors. What was the best piece of advice that you've actually ever gotten from a mentor? And this is open, Angelica or John.
I can go ahead and share my story. So one of the best piece of advice that one of my mentors gave me was that it's okay to take a minute and reroute your strategy or your goals, or how you're going to get to your goals. As I mentioned before, my story and the path that I took to get here was a little bit different. I thought for a long time that all I wanted to do was work in airplanes and help build airplanes and design airplanes. But in the process, I realized that I really enjoyed simulation. It was really cool. I really got into the software side, and that's why I decided to do my master's, which was never in the plan to continue going to school. But then once I started my journey in my master's degree, I discovered that I really enjoyed virtual and augmented reality, which was another interesting twist in my career path. So I was kind of stuck and worried, really, because I didn't know how I was going to take my aerospace degree with my simulation master's and now my newfound interest of virtual and augmented reality, and kind of tied all those in together and, come up with a good career and professional path. So I'm very thankful I did. I'm thankful for the opportunities that I've been given, and it actually was a great piece of advice to kind of step back and just let things take their journey, and they'll figure themselves out.
Very good. Excellent. Another question came in. Is this your dream job?
I'd say as far as I'm concerned, I think so, yeah.
That's cool. Do you guys have any favorite NASA memories that you'd like to share?
Well, let's see. Well, right when I got here, yeah, a lot of it's been able to see. When I was growing up, like I said, I never really thought I was going to be in the space industry. I always kind of took, glances here and there, and knew there was an International Space Station. Didn't know a whole lot about how many spacewalks or how many resupply missions actually go on all the time. And so when I got here, it was a little like drinking through a fire hose in a good way, because there were all these people with so many decades of experience, and I finally step in and I get to see all of this interesting stuff. So within the first couple months of me being there, I got to go out to the NBL, the Neutral Buoyancy Lab, and see one of the spacewalks that we're going to be working on while they were practicing it. And so I got to sit up in the command control room and watch what they were doing. And then a few months later, I actually got to see the live stream that they send out to see that exact same spacewalk that we helped them build. And so it was kind of a really neat connection moment between everything.
Oh, that's awesome. Angelica?
So I think it's kind of similar to Jonathan. One of the highlights of my job really is to be able to interface with not just other engineers that train astronauts, but actually see the astronauts use the tools that we create and build and modify for them. So I think overall it's the whole process of being able to develop the tools that they're going to be using, and then watching them use it and give you feedback on those tools. I think that really is the highlight of what we do. And obviously just, meeting astronauts on the weekly basis is pretty awesome.
Okay. And, education is definitely the key to success. I mean, however, it's experiences which open new doors of opportunities altogether. And those synergies between trainings and at the same time, the collaborations altogether. Let me ask you this. How much time do the astronauts spend training on VR?
Well, so that depends. With us, it's a different training regiment. We train them in the safer. We also train them in we have a mass handling system. And generally speaking, we see maybe Angelica trains it a lot more. She'll have better input on how often they do it. But it's usually 3 or 4 parts to the course, and then they do the refresher training that she talked about. And as VR becomes more and more popular, a lot of groups at NASA are starting to use VR to train them in their own systems. And so even beyond us, it keeps growing and growing, this amount of virtual training, and not just in VR, but also in augmented reality. And so we're going to see how that technology can be used both to train them on the ground and then eventually take that up to space, so then they can put on AR to then train and help them go through different procedures up there too.
Okay, very good. So life at NASA, work, just trying to build a balance all together. Can you tell us about any career challenges or obstacles that you may have had to overcome while working at the agency?
I wouldn't say really career challenges. I would say more of new things that I'd had to learn here in the agency. So we have a lot of custom built homegrown tools, such as our graphics engine. Jonathan mentioned Unity, and that's a pretty good graphics engine that a lot of gaming industries use. But ever since the lab started back in the 90s, those tools weren't necessarily readily available for us to use for simulations. So we built our own. So graphics engines, simulation infrastructure, things like that were not things that were taught at school. That when I started working and as I developed in my career here at NASA, I've had to learn how to use and kind of learn how to develop more additional tools using that. So really, I think it's like any other job. There's things you have to learn, and there is things that you have to learn quicker than others. So I wouldn't really say it's a challenge. I just think it's part of the job.
Mm-hmm.
All right, fantastic. Um, do you guys have any final thoughts or advice for our students out there?
Definitely pursue, if you have interest, pursue something. And the way I got involved with the VR center, which kind of set me off on the chain reaction path to end up at NASA, was I saw it, I reached out and said, hey, I'm really interested. You don't even have to pay me. I'd love to come learn things. And, I came in for the interview and so on and so forth. The rest is history. But being active about not only learning what you want to know, but also reaching out to those who also have the same passion. Generally speaking, if you share that passion, they'll be very interested in listening to you and excited to help grow that in you. So try and stay as most involved as you can, and don't be afraid to reach out to those who have the same passion.
Excellent.
Yeah, I definitely agree. I think just doing what you like and focusing on that, but at the same time, finding people that are like-minded and like the same things and want to do somewhat of the similar things. Um, that network and that relationship really is what keeps you motivated, keeps you going, and encourages you to continue pursuing everything you want to do.
Excellent. I think those are some great final thoughts on this end. Well, looks like we're just about out of time for today. But before we go, we actually have a student challenge for all the students. So it's actually called the Coding Sim, which stands for Crew Orbital Docking Simulation. So the students will actually get the opportunity to create the code to simulate a spacecraft docking with the International Space Station. Now, the challenge is to use the computer and to utilize computer science to find a solution that allows a user running your code to actually dock with the station. So we're going to include that link here on YouTube for you guys, as well as a guide and resources to be able to help you students out with the coding sim. So we hope that you will actually share your work on this activity with us at hashtag NextGenSTEM. Now, two more things before we wrap up. I want to say thank you to Angelica as well as to John. It was an honor to be able to get the opportunity to speak with you guys and to learn more about the cool work that you both do here at the National Aeronautics and Space Administration. And I really hope that you both had fun today. Lastly, we invite you to come to our next STEM Stars chat. It's going to be on May 28th, where we're going to actually learn more about water filtration. So thank you, everybody, for attending, and we will definitely see you guys next time. My name is David Alexander. Take care and have a great day.